Hi guys, this is Miss Berg again. This is actually going to be the very last um, lesson of all the chapters. So this is going to be the chapter 11 review. So we're going to go over that. There's not going to be a test. However, I'm going to start doing live Zooms again, where I'm going to have like old state test release questions, and we're going to I'm going to give you time to try and do it in class with me. However, some of you don't like to turn on your cameras. So if you're one of those people, I still need you to be sure me. You guys are gonna and take pictures of the papers that you guys do with me in class, and then just submit me that picture so that you did it with me, write it on your own. What I'm going to do is I'm going to put up test release questions, give everyone a chance to kind of do it on their own, and then you're going to then give me your answer through the chat box. What you think it is. It's only going to be private, so no one's going to be able to see what you are saying except for me. So I want everyone to put like through the chat box what you think is the answer, and then we're going to let everyone try it, and then we're going to go over it together in class and talk about it, discuss it. And if you have any questions, that's the one time you can ask me. And then we'll go on to the next question and that kind of stuff. So I want you guys to do more practice questions that you will see on the state test. So that is really what we're going to be doing on our live Zooms. So that will be starting next week that you guys see this. So it will be on that Monday. So I'll have to put up a Zoom link for you guys to get to it so that you guys can join us on our live Zooms. It will be from 9 to 10:15. So that will be our live Zooms every day, Monday, Tuesday, Thursdays and Fridays. So we will be doing that every day from 9 until 10:15. So do join us for that. If you cannot make it, then you are going to have to still do it with us. Please try it on your own. I don't want you just giving me the answers without you guys trying it on your own. I want you to try it on your own first and then put down your answers, but you would have to still submit me pictures of your papers that you did in class with us. So please make sure you are doing that so you can get the credit for being there. All right. I'm going to switch this around and we're going to talk about the review. All right, so this one says, Fran drew a triangle with no congruent sides and a right angle. Which term accurately describes the triangle? Mark all that apply. So remember when we are doing this, it tells us like it's describing the sides and the angles. So in this case, we have one right angle. So if we have a one right angle, then remember it is a right triangle for the angles. Is it acute? No, because it is a right. We could also go back to that chart to help us, which is, I think it was 11:2. So yes, this is where we did it. This was page 643. So remember, we have to pick one from this column and one from this column. So this column was your right triangle because it did have a 90-degree angle. And then it said 0 congruent sides. Well, if none of the sides are the same, it is a scalene. So therefore, it had to be a scalene right triangle. All right, this one says Jose stores his baseball cards in a box like the one shown. So here it is. It says use the numbers of the symbols on the tiles to write a formula that would represent the volume of this box. Symbols must be used, can be used more than once or not at all. So what formula would we need to solve this? So the formula we would need is we could do length times width times height for this to find the volume. So volume is length times width times height. So what number should we be putting in for this? Well, you could put in 8 times 10 times 3. Now, again, you can just multiply however you would like. In this case, I'm just going to do 8 times 10. That would be 80 times 3. So 0 times 3 is 0. 3 times 8 is 24. So your answer would be 240 cubic inches would be the volume of that. Next, it says Mr. Delgado sees the sign while he is driving. Choose the values of the term that correctly describes the shape that Mr. Delgado saw. The figure has how many sides and how many, left out a word, how many angles. So how many sides does this have and how many angles does this have? Well, you should be seeing this is a 1, 2, 3 sides. So if it has 3 sides, then it will have 3 angles. All of the sides are congruent. So the figure is not a polygon, a regular polygon, or not a regular polygon. Well, this is, remember, when all the sides are congruent in a triangle, if all the sides are congruent, and then all the angles are going to be congruent as well when it comes to a equilateral triangle. So in this case, this is considered a regular polygon. All right, next. Okay, this one is you have to find the volume of this composite figure. All right, so this is just where it gets a little too much, but it's okay. We will be all right. First of all, what I would do is I would pick corners on each one of these and do a forward and backward L of all of these. So that would be one. It'd be the second one, and then we have a third one. All right, so now we got to find the volume of this one, and this one. So let's work on the one at the bottom. Well, this one is 6. So the bottom one is 6 by how high? Well, I can go ahead and look around. Well, this one is saying 3, but that is from here to here. So this one is actually telling me from here to here is 1. So that is times 1. So that is a 1. And then how much going back? Well, I have to kind of follow that number. This and this are the same, which this and this are the same, and this and this and this. Well, this one is telling me how far deep that is, and it is 3. So this part right here would be 6 times 3, which is 18 for this bottom one. All right, now we're going to go to this one. Again, this is how high this is. Well, from here to here, it is telling us that it is 2. So if that part is 2, we don't need that part. We need everything but that part. So 6 minus 2 is 4. So this is 4. By how much back? Well, that's still the 3, and then how high is still a 1. So it is a 4 by 3 by 1, which is 12, times 1, which is 12. So this one is 12. And then this one is, again, how high. It is still telling us it is 1. Now this part is telling us another 2 is going to be gone from this. So 2 And then this is another 2, so therefore 2 plus 2, that's 4. Minus 6 is, that means that this has to be a 2. And then how far deep, that is still the same thing, which is 3. So therefore, to find that, it would be a 2 by 1 by 3. So that would be 2 times 3, which is 6. So to do this, you would do a 6 plus 12 plus 18. So that would be 10 plus 6 is 16, carry your 1, and that would be 36. So therefore, this would be 36 cubic feet. All right, next one, it says match the figure with the number of unit cubes that would be needed to build each figure. Not every number of unit cubes will be used. Okay, so in this case, we have to count this. Well, the problem is that this is up on a level. So that means that there's ones underneath these for it to be standing up on two levels. So therefore, we had to figure out this bottom part. Well, this is 3 by 2. 3 times 2 is 6. So this one would be 6 on the bottom, but then 7, 8, 9, and then this one would be 10. So therefore, this one should have been linked with 10. And now we go to this one. This one is a perfect rectangular prism. So you could have done length times width times height here because there were no gaps or overlaps. So therefore, we could have done a 3 by how many going across is 2. How high is 2? So 3 times 2 is 6 times 2. So you do 6 times 2, that is 12. So therefore, this one would link with 12. Also, you could have saw how many are in each layer, which is 6, and then another 6 below it that is still telling you 12. And then this one, the only thing you could do is just count. So this would have been 1, 2, 3, 4, 5. This is 6, 7, and an 8, and this is 9. So therefore, this one should have been with 9. All right, you are not going to do 6, so we're going to go over to the next one. It says Javier drew the shape below, shown over here. Choose the value in the term that correctly describes the shape Javier drew. So what I want you guys to try is to try this one on your own. Go ahead and count the sides. So please pause this and try this one on your own. All right, so if you did do it, it is telling you that each side is all the same. That's why there's a hash mark. Also, each angle is the same. There's just one little rainbow. So therefore, if you counted this, this is 1, 2, 3, 4, 5, 6, 7, and 8. 8 sides. So if you don't remember what an 8-sided shape is, this is when you go back to 11.1, which is on page 637. And you go and you look for the size that has 8 sides, that is an octagon. So it has 8 sides and 8 angles, and the figure is a regular octagon because all the sides and all the angles are all the same. All right, this one, it says Victoria has 1-inch cube to build the rectangular prism shown. Find the volume of this rectangular prism. Again, I want you to try this one on your own, so please pause it and try this one on your own. All right, so what you should have done is you should have multiplied all 3 of these numbers. Again, it did not matter which order you multiply it in. I think it is easier if I do that. 12 times 6. Well, what is 12 times 6? 12 times 6. 6 times 2 is 12. Carry your 1. that would be 6 plus 1 is 7. So this one would be 72 cubic inches. All right, next, Nancy drew a scalene obtuse triangle. You are going to indicate whether the figure below could be that triangle that Nathan drew. All right, so first of all, you got to look to make sure that one of them is obtuse. This one is definitely obtuse. And then does it look like these are all different sizes? Like you could sit there and you can try and put this together and then come over and look and see that those do not match as well as this one is. So therefore scaling means all different sides. None of them are the same, and there's an obtuse angle in it. So yes, this is very possible that this could have been 1. Also here, you could have turned this around so it's easier to look at. Now this one, you got to be careful. It did not give you this symbol. So if you took a protractor to it, it is like slightly off. So if I had to guess, it's probably like a 91 or a 92 degree angle. So yeah, it is slightly obtuse, but it's still obtuse. And then you could also sit there and measure it with your fingers if that would help. And you will see that none of these are the same. So this is another possibility that Nathan could have drew. Now here, could he have drawn this? And this is where you should be saying, okay, is this have an obtuse angle anywhere? And you should be saying, no, it just has a right. So therefore, this is a no. There cannot, if it's a right angle, that cannot be an obtuse triangle. All right, next. Next one, it says the shipping crate holds 20 shoe boxes. The dimensions of the shoe boxes are 6 inches by 4 inches by 12 inches. They want you to select true or false for each statement. Each shoebox has a volume of 22 cubic inches. So to figure out what the volume of each shoebox is, you should be multiplying these because it just said 1 shoebox. And they're telling you, here are your dimensions. It is a 6 by 4 by 12. Well, 6 times 4 is 24 times 12. Well, let's see what that is. That would be 8 and 4. Bring down your 0. 1 times 4 is 4. 1 times 2 is 2. This would be 8, 8, and 2. So is it 22 cubic inches? Absolutely not. And you could have probably have told that by just looking at the first part. 6 times 4 is 24. So that's obviously way too high already. So this is a false. Each crate has a volume of 440 cubic inches. So remember, it says each crate holds 20 of these shoe boxes. Now this is telling you how much 1 shoe box is. So to find 20 of them, I would have to times this by 20 to figure out that answer. So I'm going to do that right now. This would be 0 and 0 and 0. Then bring down your 0. Then 8 times 2 is 16, carry your 1. 8 times 2 is 16 plus 1 is 17, carry your 1. 2 times 2 is 4 plus 1 is 5. So that would be 5,760. And it's saying that you should have had 440 cubic inches. So therefore, this is also false. Now it says if the crate could hold 27 shoe boxes, the volume should be 7,776 cubic inches. So they're saying, well, what if that crate now can hold 27 shoe boxes? It should come out to be this as a volume. So let's see. This is again 1 shoebox. So now they're saying, now figure out what 27 shoebox crate would be. So 8 times 7 is 56, carry your 5. 8 times 7 is 56 plus 5 is 61. 7 times 2 is 14, plus 6 is 20. Okay, so that is all done. So now we're going to bring down the 0, cross out any remainders here, then go 8 times 2 is 16, carry your 1. 2 times 8 is 16, plus 1 is 17, carry your 1. Then 2 times 2 is 4, plus 1 is 5. So this would be 6, 7, 7, 7. So they're saying it should be 7,776. And this is true. Please make sure you are showing all this work with me on all of these. If I'm showing work, then I want to see that you guys did your work. I just don't want you filling in your answer and that's it. Please do all the work with me as well. Also, part A, we are not going to be doing that, but let's talk about this part, the part B part. It says Mario is making a diagram to show the relationship between different kinds of quadrilaterals. In the diagram of each quadrilateral on the lower level can be described by quadrilaterals above it at the higher level. So Mario claims that a rhombus is sometimes a square, but a square is always a rhombus. Is he correct? And explain. All right, so we're getting down here. If we did the parallelogram and did the quadrilateral hierarchy to help us look at it, this would be your trapezoid over here. Then this extends, this is a rectangle, and this is a rhombus, and then they come together and are square. So remember, going up is always, down is sometimes, and side to side is never. All right, so they're saying that he claims that a rhombus is sometimes a square. So a rhombus went down to a square. Rhombus is sometimes a square, but is a square always a rhombus? A square is going up with a rhombus. That is going up, so that is always, since they are connected. So this is true. So what we're going to say is yes. A square has 4 sides that are congruent / equal, which satisfies a rhombus's definition. A rhombus doesn't have 90-degree angles. So it isn't always a square. Because remember, you could have a rhombus that looks like this, where they don't have their 90-degree angles. All right, number 12, we are not doing that one. Now we're going to go to 13 here. It says Mark packed 1-inch cubes in the box with a volume of 120 cubic inches. How many layers of 1-inch cubes did Mark pack? So they're saying that this entire volume is 120 cubes. So what we need to do is we need to do volume equals length times width times height. All right, so what they're saying is how many layers, how many high do we have? Well, we do know our length and our width by if we just counted. So this would be 1, 2, 3, 4, 5, 6, 7, 8. This would be an 8 by 1, 2, 3. So 8 times 3 times our height. We really don't know our height yet. Equals our volume, which is 120 in this case. So 8 times 3 is 24 times h will give us 120. So in order to figure this out, I actually have to work backwards. Instead of doing a multiplication problem, I actually should do the opposite of that, which is using a division problem. So now I got to see how many 24s will go into 120. So can 24 go into 1? No. How about into 12? No. How about into 120? Yes. So this is where you're going to have to figure out how many. So remember, if you have no idea where to start, always start with 5. So 5 times 4 is 20, carry your 2. 5 times 2 is 10, plus 2 is 12. So that would be 5, which would be 120, nothing remaining. So therefore, 5 layers does satisfy that. So the H had to be 5. All right, here is another one of those composite ones. So in order to do this, the first thing that you should be doing is cutting it into 2 different boxes. So again, pick a corner, do a forward L and a backward L. These are the dimensions that you need, as well as these are the dimensions you are needing as well. So in order to do this, I can do down here, length times width times height. And then this one is length times width times height as well. So this one you would do a 10 by 6 by how high? Well, you just follow it. This one is saying 7, but that's from here to here. So we have to go this way. That would be 4. So that one would be 24 times 10, which is 240 for this one. Now we have to figure out this top one. So this going back, how much is that? Well, that is still the same number, which is 6. Then what is this number? Well, I could follow it. This one is telling me 10, but that's from here to here, so that's not going to help. But if I keep on going this way, up, that number is telling me what it is. It is a 4. And then how high? Again, I have to go searching, and it is telling me it is 3. So in this one, I would do 4 times 3 times 6. So that would be 12 times 6, which is 72. So in order to do this now, this is 72, and this is 240. To figure out the answer to this, I would have to take these two and add it. That would be a 2, 11, carry your 1, 3. So that would be 312 cubic centimeters. All right, next. The next thing here, what I would do is I am going to end up taking this, oh, sorry. This could be a possibility still. I just wanted you to take this part out. All right, a blank is always a parallelogram. So in order to help us answer this, again, I need to have that hierarchy. So I'm just going to do this very quickly. This is the rectangle. This is the rhombus. And then they come together and are a square. Remember, going up is always, going down is sometimes, And going side to side is never. All right, so blank is always a parallelogram. So parallelogram to a square. So is a square always a parallelogram? Is a rectangle always a parallelogram? Or is a square always, oh, sorry, a trapezoid always a parallelogram? So then this one is, the next one is blank is always a rhombus? So we are only using these numbers. So these ones right here. So what is always a rhombus? So is between a rectangle and a square here. So is a rectangle always a rhombus? Or a square always a rhombus? Well, square goes up from a rhombus, so therefore this is always a rhombus, a square. And then the other one is this one would have to be a rectangle. Even though this is why I didn't like this question, because yes, a square is also always a parallelogram as well. So that's why I'm not a huge fan of this question, because that was like a trick question. This could have been square up here as well, because a square is always going to be a parallelogram, as well as a rectangle is always going to be a parallelogram as well. The only thing that would not be right here would be your trapezoid. All right. The next thing, I'm going to skip 16. I'm going to go to 17. Ken keeps paper clips in a box that is in the shape of a cube. Each side of the cube is 3 inches. What is the volume of that box? So it says a cube. Now remember, on a cube, everything is the same dimensions. So if they already told you that one side is 3, then what is all the other sides going to be? They're all going to be 3 as well. So therefore, the length times width times height, everything will be a 3. So that would be 9 times 3 is 27. So this one would be a 27 cubic inches. Okay, and then the last one, I want you to try it on your own. Just go ahead and fill this all in. Please pause and try that on your own. All right, so Monica used 1-inch cube to make a rectangular prism shown, and you're going to write the values to make each statement true. Each value can be used more than once or not at all. Each cube has a volume of blank cubic inches. Now we're saying each cube is 1 inch. So they're saying just every cube is 1 inch. So therefore they would all be 1, 1, and 1. So therefore 1 times 1 times 1, that would be 1 cubic inch here. Now each layer of this prism is made up of how many cubes? That means that bottom layer. So in this case, to find that bottom layer, you would do a 4 by 5. 4 times 5 is 20 cubes. Then how many layers are there? Well, going up, there are 3 layers. So the volume of this prism, you would have to do 20 times 3, which is 0 and 6. So that would be 60 cubic inches. And that is it. Make sure you are showing pictures of each of these, and make sure all your, if there are any work, that the work is shown as well. All right, I will see you guys in live Zooms. Bye, guys.